In this video, we will be exploring the properties of isosceles and equilateral triangles. An isosceles triangle is a three-sided figure with at least two sides of equal length. The congruent sides of isosceles triangles are called the legs, and the non-congruent side is called the base. The two angles adjacent to the base are called the base angles. The angle opposite the base is called the vertex angle. Isosceles triangles have some interesting attributes that make them very useful. One of these attributes is the base angles theorem. The base angles theorem states that if two sides of a triangle are congruent, the angles opposite them, also known as the base angles, are congruent. This means that every isosceles triangle also has at least two angles that are congruent. The converse of the base angles theorem states if two angles of a triangle are congruent, then the sides opposite them are also congruent. This means every triangle that has two or more congruent angles is isosceles, even if no additional information is given about the sides. Let's use the base angles theorem to help us solve for the values of x and y. In this diagram, we have an isosceles triangle with base angles of x and y and a vertex angle of 40 degrees. According to the base angles theorem, the angles opposite the congruent sides of an isosceles triangle are also congruent. So x is opposite of that congruent side, and y is opposite of this congruent side. And they themselves are congruent. We also know that all the interior angles of a triangle add up to 180 degrees. So that means that angle x plus angle y plus the 40-degree angle will be 180 degrees. And we can subtract 40 from both sides. X plus y equals 140. So if you add x and y together, they will add up to 140. But since x equals y, each of the angle measures will just be 140 divided by 2. Which will be 70. So x will equal 70 and y will equal 70. Here we have a triangle with two congruent angles. Now, even though we don't know the lengths of either of the sides, I know this is an isosceles triangle because the two congruent angles are the base angles, and the sides opposite them have to be congruent to each other. Now we have expressions for how long each of those sides are, and since we know that those two sides are congruent to each other, we can set those two expressions equal to each other. So 3x plus 3 equals 5x minus 9. Now we can solve this equation to figure out what the value of x is. Subtract 3x from both sides. And you get 2x, add 9 to both sides, and you get 12. Divide both sides by 2, and x will equal 6. Now let's talk about equilateral triangles. An equilateral triangle is a triangle with three sides of equal length. A lesser discussed aspect of equilateral triangles is that they are also equiangular, which means that all three angles are also equal in measure. Since there are 180 degrees inside of a triangle, and all three angles are the same, each angle will be 180 divided by 3, which is 60 degrees. So every equilateral triangle has three 60-degree angles inside of it. In this diagram, we have an equilateral triangle and an isosceles triangle, and we have some missing angle measures that we are looking for. Now we can use the properties of equilateral triangles and the theorems associated with isosceles triangles in order to solve for x and y. We can start off by remembering every equilateral triangle is also equiangular, which means that all the angles have the same measure, and 180 degrees divided by 3 is 60 degrees. So each of these angles measures 60 degrees. We also have a right angle marking right here. That means that the acute angle at the top of the picture, that is one of the base angles of our isosceles triangles, has to measure 30 degrees. Because that, with the 60-degree angle of the equilateral triangle, will add up to 90 degrees. Now, that 30-degree angle that we just wrote is a base angle. The other base angle is x. So x will also measure 30 degrees because those two base angles are congruent inside of an isosceles triangle. Since we know there are 180 degrees inside of a triangle, and each of the base angles are 30 degrees, we can subtract those two 30-degree angles from 180 to determine what y is. 180 minus 30 is 120. So the angle represented by y is 120 degrees. So y equals 120. Thank you for watching, and I hope you have fun using the properties and theorems associated with isosceles and equilateral triangles.